Minasan, konnichiwa. That's all the Japanese I can speak. Because I just Googled that up, but I'm very excited to be here in Tokyo. It's my first time I'm presenting here, so thank you very much to attend the session. I try not to speak too fast, but I had a few words translated in Japanese into my slides, so I hope that will help. My name is Olivier Klein, but everybody calls me Ollie. And also got a Chinese name, so if you wonder why I have Chinese characters there, it's because I'm actually based out in Hong Kong. Now today I want to talk a little bit about, why we want to go serverless, and what serverless really means, what kind of services we can use to go serverless, and why we should only compute when it actually matters. And the first thing I want to talk about today is if you think about the traditional way of building architectures, then very often we started in a monolithic kind of approach. One big system with lots and lots of modules and lots of classes attached to it that we package into one big file and then we push it out to a server. That was the traditional way of doing things. And obviously, as probably all of you know, this is actually quite an anti-pattern these days. It's very difficult to scale a monolithic system. It creates a single point of failure very often because if that one system or one component is down, then everything goes down. It's not very fault tolerant. If somebody pushes a new piece of code, it might break everything around it because everything seems to have dependencies. And that also makes it very difficult to work across different teams. Right? If I push a piece of code into my module, it might break other people's module. If you use one single database, we have a scenario where I might change the schema of the database, and I might break some of the queries of another team. So a monolithic architecture is not the way to go. And these days, we don't do that anymore. We do something which we often refer to as microservices. So to have many of those individual services that we build, and they all talk to each other via an API, and they all have potentially independent databases. And that is great. Now, this scales well. It's easy to develop across different teams. And if we look at the definition of microservices, then it's specifically around creating a system from a collection of small, isolated services that talk to each other, each of which owns their own data, so a polyglot persistence, and that allows us to be scalable and resilient to failure. So microservices is a great concept. It works very well, and Amazon.com or Amazon Web Services is also built in exactly that manner. Lots of small microservices that talk to each other via an API. Now, I wanted to quote the CTO of my company, who's called Dr. Werner Vogels, and he likes to say this one thing. He says, no server is easier to manage than no server. And we introduced, in Amazon Web Services, we introduced a service called AWS Lambda, which potentially now becomes the approach to build microservices without managing any server, without actually running a server, without thinking about a server, so that we can say that an architecture that looks like this, a microservice architecture like this, instead of running and maintaining many servers or Docker containers or whatever it is to make this microservice architecture happen, we're just going to use a combination of AWS Lambda and a few other AWS services that are completely serverless. Now, if we architect to be serverless, why do we actually do that? Why do we not want to take care of servers anymore? Well, the concept of serverless is to say it is fully managed. I don't need to think about how many servers, how much capacity I need. I don't need to provision anything. I have the concept of zero administration. I don't need to worry about, is it the latest operating system version? Do I need to patch something? And the other element is about high availability. If you build a system, you don't want it to go down. If you build a website, if you build an application, you don't want that application to go down. And to achieve that, you want to have multiple data center facilities, multiple servers, etc., but you don't want to take care of that. So you want it to be fully managed. And probably a lot of you in this room are developers. And as a developer, I like to focus on my code. I don't like to focus on a server. So if I build serverless, I can focus on my code, which allows me to innovate much more rapidly. Just push the code, try it out, roll it back, etc. Very fast and efficient, which allows me to reduce the time to market of the application that I'm building. And the last thing that is very important when we talk serverless, we want to use services that automatically scale. Automatically scale to any amount of throughput that you have against the system, but also automatically scale back so that you don't pay money for something that you don't use. Now, within AWS, Amazon Web Services, we have many different serverless options. Those range from services like storage, like S3, to compute, Lambda, gateways, user management with Cognito. We have networking, security, and monitoring services that are all completely fully managed. Databases, messaging services, content delivery services, machine learning, or Internet of Things, IoT-specific services. And all these services adhere to the concept of fully managed, highly scalable, and highly available. Now, for some of you who might not have heard of AWS, Amazon Web Services, actually provides a global infrastructure where we deliver those services. Currently, we have 13 regions across the world, and that includes one region here in Tokyo. Now, a region is not a single data center. We have a concept that is called availability zones, AZs in short. And availability zones are clusters of data centers within a region. So if you look at a region like Tokyo, we actually have 3 availability zones, 3 clusters of data centers. And the important part about those availability zones is that they have independent network connectivity, independent tier 1 transit provider, and independent power grids, and also independent risk floodplains. What that means is that you reduce the single point of failure. So if you build in a region across multiple availability zones, then we can tolerate a complete failure of a power grid, a complete failure of a data center cluster, and our application still works because we designed to be in multiple availability zones. And what I'm going to show today with the services that we talk about, like Lambda, they automatically use multiple availability zones within those regions. And Lambda, by the way, AWS Lambda, is also available here in Tokyo and a few other regions in Asia, like Seoul, in Singapore, and also Sydney, if you consider Australia being part of Asia. Now, some of you might ask yourself, if you haven't used AWS Lambda, what is AWS Lambda actually? AWS Lambda allows you to run your piece of code fully managed and highly available in a cloud environment. So we scale it across multiple availability zones. We run the code as often as you call it, but we only charge you for the execution time of your code. So only if your code runs, you pay for it. If your code doesn't run, you pay nothing for it, and yet you have an armada fleet of servers sitting there and waiting for the next million visitors to come. Now, how do you call AWS Lambda? You can call it via an API call. So within AWS, every service has an API. Thus, it's called Amazon Web Services. Everything is a RESTful API. And AWS Lambda also has an API. So that is how you can call your code. But there's also another interesting approach in calling your code, which is through a state change in your environment. So if you have a new file in your storage bucket, if you have a new information in your database table, call your Lambda code. If you have a new message in your messaging stream, call your Lambda code. Fully managed, and we automatically scale to the amount of throughput that you have on your message stream, on your database, on your storage bucket, etc. And you'll find that AWS Lambda currently integrates with a variety of endpoints that range from data stores like S3 or storage service, DynamoDB, fully managed NoSQL database, Kinesis, Cognito. Other endpoints would include our API gateway, AWS IoT, also our Amazon Alexa voice services, and I'm going to demonstrate later on how we can use this device, which I have here on stage with me, and Amazon Echo, repositories like CloudFormation, CloudWatch, CloudTrail, etc., and also event message services, and in some scenarios, even scheduled functions. So if you want to say every 5 minutes, every hour, call my piece of code, that is possible. Now, if we think about how we build application backends, going back to that microservice thing I was talking about just earlier, generally you have your PC, your desktop, your mobile, your tablet, your laptop that connects to a certain backend logic. And then from there you generally connect, read, and write from a database. Now, if you translate that into serverless microservices, then it would look like this. You would use a service called Amazon API Gateway, which is your entry point to the microservice. You would use AWS Lambda to run your piece of code, your function, your microservice. And you would then use a fully managed database service, such as, for example, Amazon DynamoDB, which is our fully managed NoSQL database. So no servers involved here. And if we think about microservices, this allows us to build lots and lots of these individual independent microservices now, because for every microservice we use an API gateway call and an AWS Lambda function behind, independently of each other. And even the data store, the database table, independently of each other. So we can create, for example, a user microservice, and then maybe a checkout microservice, maybe an order microservice, maybe a payment microservice, and all have their own individual Lambda functions and all have their individual data stores, serverless, fully managed. What is Amazon API Gateway? Amazon API Gateway is basically, again, our fully managed service to create scalable, RESTful APIs. So an API Gateway service that allows you to put a front door in front of your API. And that API can be on a virtual server, an EC2 instance in Amazon, can be on your on-premise. If you currently have a data center, for example, you can even put it in front of your data center. But today is about serverless. So today, we're going to put it in front of AWS Lambda. Now, Amazon API Gateway is actually powered through our global content delivery network. So earlier when I showed that map of the 13 regions that we have, we also have 63 different edge locations all across the world. And Amazon API Gateway is using this. If you build an application, you want your end user to have a low latency to your first API call. With Amazon API Gateway, your end user is redirected to the edge location with the lowest latency, and your API call will actually originate from there. In addition to that, the service will also protect you against certain attacks. So for example, distributed denial of service attacks, DDoS. So Amazon API Gateway will give you protection against DDoS attacks. And it also allows you to throttle your user. If you build an application, especially, let's say if you're a startup, you often have a model where you say, I have a free plan, I have a basic plan, I have a power plan. And the free plan, maybe you only want to give 5 API calls per second. But the power plan where somebody is paying, you might want to give him 100, 1,000 API calls per second. That is what we can do with the throttling capabilities of API Gateway. In addition to that, if we think about building microservices, we generally want to have multiple stages. Development, test environments, we want to have production environments. With API Gateway, we can, again, create multiple of those stages and then move it around. I'm going to show later how we can do that. Now, I thought to make this a little bit more interesting, let's actually try to create a demo and show you live how that would look like. And the idea here would be to say, could I create a webhook for my Facebook page and then use Amazon API Gateway and AWS Lambda to actually detect if somebody posts something on your Facebook page. Facebook will notify us with an incoming webhook, and then I want to notify my team in my Slack channel via an outgoing webhook, and also store the post that was posted into DynamoDB. Now let me just figure out the mic stand here. Yeah. So what you see here actually is, I'm just going to hit the refresh button here once to make sure we're online. Great, thank you very much. What you see here is the AWS Management Console, and here all the different services that you can consume within AWS. Thank you. There you go. All right. There you go. And so what we're going to use now here is basically we want to use Amazon's API Gateway service to create an endpoint for Facebook to contact us, and then we want to use a certain piece of code which basically notifies our Slack channel and also writes the information into the DynamoDB table. How does that work within Facebook? Well, basically within Facebook we have the Facebook developers stuff, and here we can actually create an application and an app. And at the same time, what I did earlier, and I did this for another event which was called Cloud Kata, I created a Facebook page. And if I create a Facebook app, I can actually tie that application back to my page. And that's exactly what I've done here. And if you have an app, you can then create, within Facebook, you can create a so-called webhook, which would, if anything changes based on the fields that you specify, it would make an API call to the endpoint that you would specify. And here, I'm going to use the API gateway that I provisioned earlier. And I said, whenever there's some new messages or new information in my feed on my Facebook page, then call this URL and inform me about it. So how would that look like on the serverless backend side of things? Well, if I open this up and I go to API gateway, you would see that I actually created, where did I have this? This is my Facebook page and the microservice. I would have an API here that I defined, which I called Facebook page webhook, where I have multiple functions on it, get and post function. The get is for the authentication against Facebook, and the post is what Facebook will call when there's a new information in my feed. If I click on this, I will actually find that if that post function is invoked, eventually we will call a Lambda function, which I called Facebook page webhook. Let's have a look at that. Just clicked on it. What you see here is the console of Lambda, and we currently look at the Facebook page webhook Lambda function. And this one will be called via, if I click on trigger, via my API gateway. So this is what Facebook will be calling. And if we look at the piece of code, I do a variety of things. I authenticate myself against Facebook, but eventually I'm going to look at what has actually changed. And then I will look at, well, if somebody posted something, I want to say his name just posted on your Facebook page with its message. And I then want to send that to my Slack channel, which I created another AWS Lambda function, which I called Slack demo incoming webhook, which will call my Slack API to actually inform me about a Facebook message, so that eventually, if I would go into my Slack channel here, I should see a Facebook post coming in here. So let's see if that actually works. If I go to this side here, and I would say, let me post, hello, serverless conference, conference Tokyo. And I will post that. What happens now, I post that to Facebook, and Facebook will obviously write that to their own databases, etc. We'll decide that, we'll notify that there's a certain change. We'll then call my webhook, and you already see it popping up here on the right side. We'll call my API gateway, which calls the Lambda function, writes it into my DynamoDB table, but also informs the Slack API that I have a new message, pushes that to the Slack API post via, again, a Lambda function, which then translates into a message in my channel that would say, Olivier Klein just posted on your Facebook page, hello, serverless conference, Tokyo. Now, I got a few other demos coming, but I wanted to start off with this one. If you think about what we've done here, is we now built a microservice that is completely event-driven. Only if something happens on my input, which is Facebook, then I call my piece of code. And then I can call another API, like Slack, for example, or like DynamoDB, which is also just another API, to continue to take that message somewhere else where I want to have it. So I created now a very tiny logic with 50 lines of code, and it just works. And this is very compelling. So we actually have customers that do exactly that. They use this combination of API Gateway, AWS Lambda, and a few other AWS services to actually build applications and platforms on top of us. And just to give you, I'll give you a few other global examples, but I also wanted to talk about a local example here in Japan. For example, Okasan Online Securities, and you can see here a quote from one of their senior guys who actually decided to use AWS to build their online trading platform and demo platform. And they also have, because it's a trading platform, they need to have a live stock market feed. What is the price of this current stock at any point in time? And they also need some form of order management. And they decided to actually build that serverless. How did they do that? Well, they used Amazon API Gateway and AWS Lambda and a variety of other services to make that happen in a serverless manner. And it actually resulted into a seventh of cost reduction and management reduction, basically. Why? Well, only if your code is called, you pay for it. If you don't call it, if there's no request against your stock market feed, then you don't pay for anything. So that's a great element of serverless. Now, if we think about building a mobile application or web application, you might ask yourself, what you showed is great, but it's an API call, right? It's a post, a get. I cannot create a website with and tell people do a post, do a get. So how do we get our web application to the browser of the end user? And here we need a few other serverless services. Specifically, we're going to use two services here. We're going to use Amazon S3. So Amazon S3, I talked about it earlier, is our object storage service. It's designed for high durability, high resiliency, so 11/9 of data durability, so really great to put files that you don't want to lose. But in the context of serverless, it will also provide you an HTTP or HTTPS endpoint to any object that you store within that storage service, if you make the object public. Which also means that you can now put any kind of files into S3, and S3 becomes like your fully managed static web server. Furthermore, if you think about delivering a web application, again, you want your end user to experience a fast performance. So for this, we're going to use CloudFront. So CloudFront is a content delivery network, so it's using all the 63 edge locations across the world, and it will cache the files on those edge locations across the world, and when somebody wants to visit the web application, he will get the content from the edge location that has the lowest latency to his browser. So if we think about delivering a web application, what is a web application? It's HTML file, it's JavaScript, it's CSS, it's images, JPEGs, PNGs, it's movie files. All of that are objects, and all of these objects, we can put them into Amazon S3, put CloudFront in front of it, and now we can deliver a web application, highly available, highly scalable, back to our browser. So if you think about a serverless app architecture, it generally translates into delivering your application via your browser, which would be S3 CloudFront, to the browser, and then you can use JavaScript to make calls potentially back to any other backend logic that you would have. And that backend logic would then be your API gateway, would be your AWS Lambda function, and if you need a data store, you can use DynamoDB, but since you can write any kind of code into AWS Lambda, you can also call any kind of other services, AWS services or third-party services, like what I did just now. I called Slack. Slack is another third-party service. And if you think about the component of the microservice here, can we make that even a little bit easier? Yes, we can. There are actually frameworks that can help you to build the combination of API Gateway and Lambda in a much more effective manner. There are many out there. There are frameworks called Apex. There's a framework actually called Serverless. On serverless.com would be the URL. And we also launched, AWS also launched our own microservice framework, or micro framework for serverless compute, which we call Chalice. And Chalice, again, is a framework to quickly, create files with the different kind of calls and function codes that you want to have, and then with one line of code, say, deploy it out. All right? So if we look at it, Chalice can create a project for us. That project generally comes with in this scenario, it's Python, where we can have multiple of those routes. So you could have many of those with your code attached. Give it a name. You just need to then say deploy it, and we now have an online URL to which this is now available for us to query. So really, really great way to quickly and effectively build serverless microservices. By the way, it's open source, so github.com/AWS-labs/Chalice. And if you haven't checked out AWS Labs, github.com/AWS-labs is our platform, our repository where we put a lot of those open source tools out. Very useful if you use Amazon Web Services. There are lots of interesting projects, not only Chalice, up there. So I figured, how about I show you another demo, and that other demo, again, would be how could we create a serverless web application now, which allows us to potentially look at comments that some people post and also post new comments into a database table, completely serverless. All right. So let me go back to my browser here. So the next thing that we're going to leverage, so obviously we're going to use Lambda and we're going to use API Gateway, what we saw earlier. But we're also going to leverage two other services, which would be S3 and CloudFront. And S3 can be used to create what we call storage buckets. Let me just load this up. And you can see here I already have a bunch of buckets created, and I also created a bucket called API Gateway Demo. Now, the concept of bucket is great because you can create a bucket and then you can put as many files as you want. There's no limitation around it. And I obviously put a bunch of HTML file, actually one HTML file, and a bunch of other CSS and JavaScript files inside here. And if we create those files, we can then eventually see that every file will get a certain endpoint. If we make it public, we can actually access it through it. As mentioned, this would already work, but as mentioned, we want it to be fast, so we're also going to use a content delivery network. For this, we're going to use Amazon CloudFront or any content delivery network that you like, and we can then use that to create a distribution and point it to that S3 bucket. And that will give us a certain domain name that we can now use to actually access this web application. Now, if you think this is doesn't look very nice, no problem. You can put in your own domain name so that it's yourdomain.com. Now let's try if that works. If I call this up, you see I actually have a certain HTML file that came back in, and the idea here is that I want to have a functionality to post new comments and load new comments, right? So if we have a look at the page source, and please don't judge me by my development style. This is quick and dirty. What I did here is I basically said if I hit the load button, I do a GET request. This is jQuery, by the way, a GET request through my API gateway here. And then whatever I get back, the data that comes back here, I'll just insert it into the page. Similarly, if I hit the post button, I'll just take my comment value field, whatever I wrote, and I send it to my create new post API function. Now, before I proceed, let's have a quick look at how these functions look like. So if I go to API Gateway here, and when I created this demo, I was actually in the US, so I actually created this demo in Oregon. And this is a good example on how the content delivery network will help to accelerate those calls, potentially. Oops. Was it not Oregon? Was it somewhere else? So, actually in Singapore. There you go. I travel a lot, apparently. It was in Singapore. No, it was also not in Singapore. Where was it? It was... I actually created it in Tokyo. Yes, I changed it yesterday. There you go, there you go. Back to Tokyo. Back to Tokyo. Here we go. But the Lambda functions sit in Oregon, actually. Here we got it. So serverless demo, where I created two functionalities, create new posts and get all posts. If we have a look at that, let's have a look at the get all post function. Again, it calls, and there you see it actually calls a Lambda function in Oregon, a get all post function. Let's have a look at this. So you'll see that this Lambda function is actually quite simple. It actually just says go to DynamoDB, look at the Lambda demo posts table, query it, and after you're done query it, basically just return what you just queried. Right. Let's have a quick look if we execute or test this function, if that would work. Tests. See, if we run this function, there is actually already one post inside here. Where would that post be stored? Well, it will be stored in DynamoDB. Let's have a quick look at DynamoDB. Here we got a table, Lambda demo posts, and here we already have one comment that has been written inside. So now, let's try this out on our demo here. Oops, sorry. And one thing that I'm going to do is I'm going to use Google Chrome Inspect to see what kind of network connectivity we have. If I hit this load comment button, you see that we actually render, hello everybody, there's a comment created without any service, which just came from the API call from the DynamoDB table. If you look down here, there was actually a request that was made against get all posts to my API gateway that called the Lambda function, called the DynamoDB table, read it, and send it back to the browser, completely serverless. Now, the same thing obviously also applies if you want to post a new comment. So actually, let's see if that works. Let's say, hello, everybody. Awesome to be in. And you know, this is actually Unicode, so I should be able to write. Doesn't want to do it now for me. Can't find. Dongjing. My Chinese is not there. There we go. No, it's not there. All right. We keep it at Tokyo. Tokyo. But we could also write kanji characters, for example, inside here, or any kind of Japanese language if you want that to happen. I actually wanted to use kanji character to write Tokyo. Now, if we do that, you'll see down here again a create new post has been called. This is now a post that has been written into the API gateway Lambda function, writes it into DynamoDB table, and then the JavaScript here rendered comment was successfully posted and reloaded then the new comments, and you see now that we now have hello everybody, awesome to be in Tokyo. And this is how we now created our first complete serverless web application, well delivered to any users across the globe because we use the content delivery network, highly scalable in the sense that you can have as many visitors as you want here, but the best element of being serverless here is also that it only costs me something when somebody actually uses it, and it only costs me the execution time of my code, which makes this a very cost-effective solution to deliver a web application. And this is quite compelling, so compelling that actually a lot of our customers are using it. For example, Coca-Cola delivers some of their web application with this combination of S3, CloudFront, API Gateway, Lambda, etc. But we also got other ones like AdRoll, which does ad data analytics, or FireEye. We got Twilio, which is a cloud telephony platform, delivers a lot of things through AWS Lambda. Thomson Reuters does their content management through it. Or the Major Baseball League, where you can actually watch the baseball. They have the second screen on their phone that is also delivered through a serverless kind of function. So serverless, quite interesting. Now, how about deployments? If you saw what I just did there, you saw like the piece of code in my browser, and if you now say, I want to update that code, would I just go into the browser and click save and then say it goes straight into production? That's obviously not a great way. That's okay if we develop, if we test, that's fine. But if it's a production environment, we do not want to make any breaking changes, introduce any breaking changes into what we deployed. So we need something around versioning. And serverless services should generally enable versioning. And if you use AWS with AWS Lambda, it actually would be versioned. So you can create different AWS Lambda function version, and every version is an immutable version of that function. Immutable in the sense that nothing around it changes. The configuration that you have set, how much memory you want to use, the timeout of the function, or even the monitoring, what we call CloudWatch, is dependent on that version. So every version has its independent different configuration, independent different CloudWatch logs, CloudWatch metrics, etc. And what you can do now is you can then create multiple versions of your function, and it will be an iteration 97, 98, 99, etc. Similar that you might be used to when you use a JIT repository or something along those lines. And the latest function would always sit in the $latest version here. And there's an additional thing which you can do. You can use what we call an alias. And with an alias, you can actually label a version release. So you could say number 98 is my stable alias, is my stable function, but my latest function would be my latest, $latest. And that allows me to now think about how could I use that to deploy. So if I create multiple versions, right, 92, 93, 94, I could say, for example, my testing environment should probably always have some of the latest version, like, for example, 94. And we can use that alias to then tag that function. And we can use the alias stable to tag the current stable function version, which would be 93. If we now want to deploy things out, we say, okay, we tested version 94 extensively, works well. We want to roll it out. The only thing that we need to do is to just change the alias of stable to version 94, and we now rolled out version 94. If anything goes wrong, if we suddenly get errors or whatever, we can easily roll back. We just change the alias, we fix the problem, and okay, now it's stable again. Let's roll it out, change the alias. Now, how does that work in the combination with API Gateway? How does that work to roll that out? Well, what I didn't show you earlier in API Gateway, apart from the resources, you also have stages. And those stages was actually what you saw at the end part of the URL. And I can create multiple of those stages. So I could create a testing, a development stage, a production stage, and all of them get independent URLs. And they can then call independent Lambda functions. Now, I talk about alias. How do we tie that back? Well, in the API Gateway, you can also have stage variables. And in that stage variables, I could, for example, say I want to have a Lambda version stable. So for my production stage, I want to call Lambda functions that have the alias stable. How do I map that? Well, when I create a resource in API Gateway, I can choose from a variety of things, but if we use serverless, we choose Lambda function. And then we give the name of the Lambda function, but we can append the version or the alias to it. And since the API Gateway can deliver that variable back, we can just say, take, in this scenario, a Lambda function named ASG spot query, but take the alias, which is the Lambda version variable, which would be stable, or which would be latest, or production, or whatever you defined. So if I now want to pin my environment to those stage variables, well, then all I need to do is I create my Lambda function, I create different versions of it, and then I create an alias around it, where I say maybe stable, maybe QA, maybe a $latest. And then I can map that to my stages in API Gateway, which allows me to then use a custom domain on that API Gateway to say, well, my function that is tagged as stable, with the alias stable, becomes my API.mydomain.com, .example.com. My development, which I might tag as always the $latest, goes to dev, the other one goes to QA, etc. Now, the last thing that I wanted to talk about today, I thought, let's do something fun. I thought we talk about serverless, we talk about web applications, and we have wonderful speakers today that talk about how to use it with front-end frameworks and how you can build, like I think, sentiment analysis and a few other things that we talk about today. But I thought, like, how could I show another application of serverless? And I specifically thought around the area of Internet of Things, and I also specifically thought, could I use another interesting Amazon device that I brought with me here. You see it up here on the screen for those a little bit further, the one in the front row. I actually got that device right here with me. This device is called an Amazon Echo device, and that device allows you to talk to what we call the Alexa voice services. So it can listen to me, and I can ask it questions. It will call the Alexa voice services in the back end to get the response, and then tells me the response. So let's try that out. Alexa, say hello.
Hello.
Alexa, what's the population of Tokyo?
The population of Tokyo is about 13,600,000.
Alexa, where are you?
I'm here and my head is in the cloud.
All right. I'm going to mute her for a while. What you see here, this is just a device. This is what we call the Amazon Echo. But this device has the power to connect back to what we call the Alexa voice services, AVS. And by the way, if you manufacture devices, you have your own device, you can use the Alexa voice services without the Echo. So the Echo is just a device that connects to it. But the Alexa voice services, again, is a serverless, and that's an area of service, a serverless service that allows you to understand what people are saying and respond to it. Now, this service is not closed. It's not that only what Amazon writes can be used. The service is open for you to actually build what we call skills. You can build your own skill set for Alexa. You can train Alexa new things. You can write your own piece of code and then have it interact with the voice of any kind of end consumer, and you can actually publish that skill to a marketplace where other users can use it. And there are actually a lot of companies that are doing that. A lot of companies that produce different devices, publish their skills back to Alexa, and then you can use Alexa to actually interact, for example, with your smart home. Turn up the temperature, turn off the light, turn on the light. You know, Philips would be, for example, a company that publishes their, can't remember the light bulb names, but they have colorful light bulbs, and you can interact with them with Alexa. Now, we call this the Alexa Skills Kit, ASK, which allows anybody to build and publish their own skills. And the way it works, it actually makes an API call to a backend. You can then write your skill there, and it delivers the result back and gives a speech output. And since we want to do that serverless, we can also use AWS Lambda to do that completely serverless. And we actually released a little SDK to make your life a little bit easy. If you want to build your own Alexa skill, then what you can do is you can use that Alexa Skill Kit. Again, it's open source. It's available on our /Amazon GitHub page, actually, Alexa Skills Kit.js. And it allows you to quickly extend and build a new skill. So you can say, I want to have an Alexa skill. I'm going to build it on top of the prototype. And whenever somebody just calls my function, I just say, hello world. Response tells speech output, and then Alexa will say, hello world. Let's try to build that in a more interesting scenario. Let's try to build our own Alexa skill. I'm going to try to do that now here. So I want to have my Echo device call the Alexa voice services with the Alexa Skills Kit, which calls a Lambda function. And then you remember the first demo about Facebook, right? Wouldn't it be great if I could ask Alexa, what was the latest post on my Facebook page? So let's try to build that service via this demo. So I'm just going to show you a few things. The first part is the piece of code. Let's open up. So what I actually created here is an Alexa skill, which I called the Lambda bot. Right? And in the Lambda bot, I created two functionalities to actually get new Facebook's post and also give me the count of a Facebook post. Where do I get that from? Well, earlier what I didn't show you was the DynamoDB table on which the earlier webhook was actually writing all those posts. So I can actually look up that DynamoDB table and just say, hey, give me the latest item in that DynamoDB table, and then tell Alexa to just tell me, tell me this user was writing whatever he was writing. And then just say, tell me. The other thing would be to get the post count. So go to the Facebook page table and just look at, what is the amount of posts that we have? We now have X amount of posts. And that's basically it. We just say export this Lambda function, this Lambda bot into a Lambda function. Let's have a look where that sits. If we go into the AWS Management Console here, and I built this one in North Virginia. See that I created here an Alexa skill Facebook page. And here's the interesting part about the Lambda function. Earlier we used the API gateway as a trigger, but another trigger could be, for example, the Alexa skills kit. So I can add the trigger. I did that earlier here. I added the Alexa skills kit to this Lambda function, and now whenever I say a specific keyword, which I defined as Lambda bot when I talk to Alexa, it would actually read this information out. So if we have a quick look at our DynamoDB table on which I stored this information. Which I put into Tokyo. I should decide on one region. I always get confused with all the regions. Here you go, Facebook page. So if you remember earlier, when we posted onto the Facebook page, I actually posted something which was Hello Serverless Conference Tokyo, which was the latest post. So if I now try this skill, if I talk to Alexa, it would call the skill, will call my code, would go to the DynamoDB table, and then would eventually return this kind of information. So let's try that out. Alexa, ask Lambda bot about new Facebook posts.
Olivier Klein was writing, Hello Serverless Conference Tokyo.
There we go. And if we have a look at how many posts we have in our DynamoDB table, it should actually say 2 posts. Let's try that out. Alexa, ask Lambda bot how many Facebook posts we have.
We now have 2 posts.
2 posts. I want to show you that this actually works. So let me delete one. Alexa, ask Lambda bot how many Facebook posts we have.
We now have 1 post.
1 post. Awesome. And why does it say 1 post? Because I'm a lazy programmer. I just put posts in the plural. Awesome. Now, a little bit of fun with Alexa here, but the power is that you can really create all skills that you want and do it completely serverless. Now, I'm slowly running out of time, but I wanted to leave you with a few final thoughts to really kick off this conference and see what other cool stuff you guys have been building. Think about serverless in a way to always plug in a front door. A front door should be an API gateway. If you use Amazon API gateway. It's a great front door to all your services. Some of them might be serverless, some of them might not be serverless yet. Please use microservice concepts. That's really useful. Polyglot persistence, every microservice should own its own data. And when you build serverless application, microservices and serverless, they love each other. That just belongs together. Think about versioning, think about stages and how you can roll things back and forward. And if you think about application delivery, it's generally done with HTML and JavaScript or HTML5 these days. So perfect application to do it serverless. Now, with that, I want to thank you very much for your attention. Thank you.